Hello guys, welcome back to C++ channel. Today we're going to be solving this interesting problem from Codeforces called Manhattan Permutations. So what is Manhattan permutation? Manhattan value of a permutation is the value of this expression. Yep, and so what we are supposed to do with this, the problem gives us k and n here, and we need to find a permutation of length n such that its Manhattan value equals k. Yeah, so what we're gonna do to solve this problem. So first, throughout this video, I will insert pictures of some math from my notebook to like show y'all my math behind my solution. Yeah, so first let's determine for what case we can't make a permutation. So yeah, here I will insert a picture. So what we can see at this picture is the maximum value that we can achieve for the permutation of length n. So what does it give us is basically if we calculate this and then if our k is bigger than this value, obviously we will not be able to make a permutation, so the answer will be no. And yeah, and now not only that, we can also notice the other thing. I will have to insert another picture here. Basically on this picture we can see that so we have p1, p2, p3, p4 to pn. So what I did, I just wrote the Manhattan value, and then it is obvious that absolute value of px minus x equals px minus x in like modulo of 2. So what that means that our Manhattan permutation can be easily written as the equation below. That means that our Manhattan value will always be even and not odd. So that means that for every odd k, the answer will also be no. I hope that's pretty much understandable. I made sure to write everything as simple as possible. So now what should we do here is, now we have to find how do we answer the test case if we can answer for k, right? So here I will again insert the picture. I know that's kind of weird, but like I still have to do it. On this picture I showed y'all what's gonna happen if we swap x and y from our default permutation. Default permutation is 1, 2, 3, 4, 5 to n. And if we swap x and y, and let's say y is greater than x, this doesn't change anything. So initially our Manhattan value of these two will be absolute value of x minus x plus absolute value of y minus y. That equals 0. And basically if we swap them, we'll have x minus y, absolute value plus absolute value of y minus x, which is, in our case, since y is greater than x, will be 2 times y minus x. So what does it give us? That means that whenever we swap two numbers, our Manhattan value increases by even number, right? I say increased because I just assume that we have an initial permutation, right? And that means that since our k is even, and whenever we change two numbers, we change our Manhattan value by even number, that means that we just need to swap the just swap enough pairs, and our answer is guaranteed to be found, right? So I will write the code, and I hope that y'all will understand it better if y'all didn't get the idea. So basically we'll do this. So I'm writing this because we're given T test cases, right? And in each test case we'll have N and we'll have K. Alright, so now let's calculate the maximum value. To do this, we'll need mx, which is our maximum value, surprisingly, and then j will be the number that we'll be subtracting from our numbers. So basically, we'll start from n, as I said, and yep, sorry. And j plus plus, because our indexes are getting bigger by 1. So now what we're gonna do is we're gonna say no if our k is odd or our k is greater than our maximum value. We're gonna instantly say no. And we'll press continue so that we'll go to the next test case, right? And yeah, if we didn't go to next test case, that means that we just say that we can find the permutation. And now let's just find our permutation. For that, I'll net vector. Yep, this is going to be our initial permutation. So now we need our x and y's that we're going to swap. Initially, they're going to be 1 and n. Actually, let me write this as this. Right. So now while k more than 0, greater than 0, I'm writing k greater than 0 because instead of just calculating the Manhattan value, I will just subtract our current value, and once k is 0, we just know that we have achieved our goal. So if k is greater than what we can get if we swap our x and y, we basically just swap them. That means that after we swap x and y, we'll have to do other operations too. So we just swap them to then k equals k minus 2 multiplied by what? Right. And x plus plus, because we just swap 1 and 9 x and y, and I will have to use other numbers, right? And now if k is not greater than this value, we will do what? We will swap and I don't write long here. Let's write long everywhere, actually. Y'all should not spam this move because sometimes it makes worse, but I don't know. Sometimes in some problems you can just not care about the memory limit, and so I just write this. In this problem, I'm pretty sure we can do this. If not, we'll have to change the code, obviously. Yep, now we just write k equals 0, so that we know that we achieved our Manhattan value, and we just exit from our while. So, and now we just print the answer. And to make a new line for our future answers. Yeah, that's pretty much the code. Yep, let's run it. Yeah, it's good. Okay, let's put some test cases, I guess. Yeah, here, y'all can see I've solved this problem before. Actually, let's make only one test case, because I said so. Yep, as you can see, hey, yo. I think the Manhattan value of this will equal. Does it? So we have 3 minus 1, which is 2, plus 2 minus 2, which is 0, and 1 minus 3 absolute value, which will be 2. So we have 2 plus 0 plus 2, which should be 4, 5. Everything is good. Let's see our code. Let's submit it and let's see what we get. Should be okay. I'm pretty much sure. Okay, test case 4, 6. Okay, I think that's accepted. Yeah, it should be. Okay, it works kind of slow because I think we are in the middle of contest right now. But yeah. Okay, I paused the video. And yeah, we got accepted. It's good. That's it. That's the solution of Manhattan permutations. This is C problem from Division 2. Yeah, it's pretty good. Thank you guys for watching this video. Make sure to like and subscribe. If y'all still got any questions, feel free to ask them in comments. I'll make sure to answer all of them as soon as I see them. Bye bye.